Next problem, x of t is equal to a cos lambda t plus b sin lambda t. T is greater than or equal to 0 is a random process where a and b are independent and normal variate 0 comma, that is sigma squared, right? Mean 0, variance sigma square. Random variables, examine the stationary of x of t. So we are going to check what is the stationary x of t this random process is, right? So given x of t equal to a cos t plus b sin t, t greater than or equal to 0, that is equation number 1. Here given a and b are independent random variable, normal variable, with mean 0 and variance sigma square. Now expected value of a, that is mean of a and mean of b given, that is equal to 0, and the variance. And before that we are taking expected value of a into b, a into b, expected value of b into a, because a and b are independent. Now expected value of a into expected value of b, both are 0, that is equal to 0. This is equation number 2. Next, variance of a and variance of b, that is also given sigma square. We know variance of a, which is equal to expected value of a square minus expected value of a the whole square, right? Expected, that is sigma square, that is given variance of a, which is equal to expected value of a square minus e of a equal to 0. So expected value of a square equal to sigma square, and similarly expected value of b square is also sigma square, right? That is equation number 3. Now to find expected value of x of t. Now expected value of x of t is equal to expected value of from 1 a cos t plus b sin t. So taking expectation to each term, expected value of a cos t is a constant taking outside, plus expected value of b a and b are random variables. So expected value applicable only for the random variable. Constant term is a constant term, you can take it outside. So sin t is equal to expected value of a and expected value of b equal to 0. So substituting the 0, you will get 0 by using 2. Now expected value of x of t is a constant, that is Roman letter 1. Now to find autocorrelation or xx tau. Now we know the r of xx tau is equal to expected value of x of t into expected value of t plus tau. So substituting x of t plus tau from 1. So you will get a cos t plus b sin t. Replacing t by t plus tau in 1, we will get a cos t plus tau plus b sin t plus tau. So multiplying each and every term inside, there are 2 into 2 terms, so we will get 4 terms. First a cos t into a cos t plus tau, a square cos t plus tau. B a cos t into second term b sin t plus tau, ab cos t sin t plus tau. Then b sin t into the first term a cos t plus tau, you will get ba sin t cos t plus tau. Then b sin t into b sin t plus tau, b square sin t plus tau. Now applying expectation to each term, a expected value of a square cos t plus tau constant, it will come outside the expected value. Similarly for the all term, expected value of ab sin t plus tau cos t plus expected value of ba cos t plus tau sin t plus expected value of b square sin t plus tau. We know expected value of a square equal to sigma square from equation number 3, and expected value of ab and expected value of ba equal to 0, that is also we know from equation number 2. Substituting all those things, you will get sigma square cos t plus tau plus sigma square sin t plus tau. Sigma square is constant, taking outside you will get sigma square into cos t plus tau plus sin t plus tau. Again we are applying cos a minus b formula, cos a cos b plus sin a sin b. Here a is equal to t plus tau, b is equal to t. So sigma square cos t plus tau minus t. So you will get sigma square cos tau, which is a function of tau only. From 1 and 2, it is a WSS process, expected value constant and or autocorrelation is a function of tau. Next we are going to see the Gaussian distribution. Gaussian distribution is nothing but the normal distribution with mean 0, variance sigma square. That is another name of normal distribution, correct? A Gaussian process, same thing. So last sum we saw given random process is a normal with 0 mean and variance sigma square. That is Gaussian process, right? A Gaussian process is a stochastic process x of t such that every finite collection of those random variables has a multivariate normal distribution. Each and every collection is a normal distribution with mean 0, variance sigma square. Normal distribution means like that only, right? Mean 0, variance sigma square. A Gaussian stochastic process is strict-state stationary, triple S if and only if it is a wide-state stationary, WSS. Here only in Gaussian process it is if and only if condition. Triple S if and only if WSS, right? Note this point. So based on this we can see one problem. X of t is equal to y cos wt plus z sin wt. Y and z are two independent normal random variable with mean 0 and variance sigma square. Now W is a constant. Prove that x of t is a strict-state stationary process of order 2. X of t which is equal to y cos wt plus z wt, that is the equation number 1. Here given e of y, e of z equal to 0, not variance e of y square. Square mean square it is given, right? Not variance, mean square. Here mean square is nothing but variance because expected value of y and expected value of z equal to 0. So that is what I mentioned, that is variance, right? Variance is nothing but e y square and e z square, correct? So given e y square equal to e y z square equal to sigma square, that is equation number 2. Hence y and z are independent Gaussian process because normal with 0 and variance 0 mean variance sigma square. E y z is equal to e y into e z because independent, that is equal to 0, right? So third equation. Now to prove x of t is a strict-state stationary, because this is Gaussian process, so we know the if and only if condition. It is enough to prove it is a WSS stationary. For WSS stationary, first e of xt is constant, r of x tau, which is nothing but a function of tau, right? That is enough. Now to find e of x of t, e of x of t which is equal to e of from 1 y cos wt plus z sin wt. So separating, so e y into cos wt constant taking outside plus e z sin omega t, wt is a constant taking outside. We know e y e z 0, that is equal to e expected value of x of t, that is mean equal to 0, which is a constant, that is number 1 Roman letter. Now to find r x x tau, which is equal to e x t and e x t plus tau. Using 1 we will get y cos wt plus z sin wt into y cos wt plus tau plus z sin wt plus tau, replacing t by t plus tau. So removing the brackets as usual, like previous problem. So we will get the expected value of y square into cos omega t cos t plus tau plus expected value of z square sin t plus tau plus expected value of y z into taking outside common because y z y are both equal, so taking outside, so applying the expected value sin wt cos wt plus tau plus cos wt sin t t plus w tau. So they are applying the values from 2 and 3, sigma square cos omega t plus tau plus sigma square sin wt plus sin wt plus tau, sigma square taking outside common So again we are using cos A cos B plus sin A sin B, which is equal to cos A minus B formula. Here A is t plus tau, B is t, so we will get sigma square cos t plus tau minus t, that is equal to sigma square cos W tau, which is a function of tau. So from 1 and 2 it is a WSS process. Because this is Gaussian process, this implies this is a SST, state stationary process, state sense stationary process. Yes, that's all. So we'll see you in the next video. Thank you.